Some of you might be familiar with what you're looking at here, but for those who don't know, this is a cast iron convector radiator, which is perfectly known as a cast iron element convector. Now, this is a Governale cast iron convector, which happens to be one of my personal favorite selections when it comes down to cast iron convectors. I've done some videos on steel convectors in the past, but we're dealing with cast iron convectors, which are much better actually. They give off more heat and they hold the heat far longer. What we're looking at is a 6-inch from wall to front, 6-inch deep or depth as far as the radiator is concerned, and we're looking at a 2 fin columns that are exactly adjacent, lined side by side with each other. And this radiator is about 41 inches or 42 inches in length. As you can see, it's currently set up with a gate valve from the bottom. This is on a 1-pipe system. You can see there's no trap valve at the end of it. There's just an air vent on this side on the end, and that's pretty much how this thing works. Pretty common for a 1-pipe system. Now, the reason why I'm doing a video on this radiator is because I want to do a test. I'm going to conduct a test in this video, which is going to pretty much prove my hypothesis when it comes down to some opinions or some analysis that people brought up to me when it comes down to 1-pipe steam systems. And I've heard plumbing supply distributors and people who work in the heating field will tell you this, that steam will travel faster through your system under less pressure. And the reason why they're going to say this, and they're going to use an analysis such as this here. Now, before I even say that, allow me to tell people what the test is going to be about. I'm going to prove or disprove that theory and show that that is completely inaccurate. But back to what I was saying now, the way they're going to try to prove this is they're going to say, well, if you think about it, you have all this steam trying to get inside of one pipe, or trying to push inside of a pipe or pipes that are of a certain size. As you see, this is 1.25 inches. They'll say things like, well, if you look at a highway or a city street, how does traffic flow smoothly on that street? Is it going to flow smooth by compacting a bunch of cars and buses and trucks on that street, or if you have less traffic on that street? Now, I can understand where they would think that this would hold some, this would be a valid point to make when it comes down to their analysis, and that's a very perfect and logical analysis when it comes down to traffic, but completely inaccurate when it comes down to dealing with steam heating systems. So what this test is going to consist of, there's going to be 2 tests that are going to be conducted in this video. The first test, what I'm going to do is I'm going to let this radiator gradually heat up. It's going to heat up along with the system. It's at room temperature along with the system. The system's been down for a little while and everything has had a chance to restore back to room temperature. So I'm going to fire up the boiler, let it run, and what this test is going to consist of, it's going to consist of a stopwatch, which I'm going to use on my phone, a fluke meter, which is going to tell us the temperature of the radiator, and how we're going to start the test is once the steam gets into the cutoff valve, I'm going to start the time on the stopwatch, and then I'm going to let it run all the way to the point where it reaches to the back of the radiator and gets inside of this air vent. And once it gets inside of the air vent's going to let us know that the radiator has been sufficiently heated and is satisfied. How will we know this and how will it give us verification? Is because the vent will lock as soon as the steam hits it. As soon as the steam hits it and that vent locks out and we hear that click sound, I will stop the stopwatch and I will keep track of the time, and we will see how long it takes for it to make that, or for it to bring that steam or heat up this radiator sufficiently. So from the time it gets into the air vent to the time it makes it, from the time it gets into the cutoff valve to the time it gets all the way into this air vent, we're going to time how long that takes. The next test is going to consist of shutting the radiator down, allowing it to cool off. Once it gets back down to room temperature, what I'm going to do before I start the system back up, I'll close this cutoff valve, this gate valve. I'll keep it completely closed, and what I'm going to do is I'm going to let the system build up maximum pressure, and then I'm going to open up this valve at maximum capacity and let steam get into this radiator. We're going to see exactly how long it takes, and like I said, once I open up the valve, what I'm going to do is I'm going to start my stopwatch again from the time it gets here, or from the time I open it to how long it takes to get into that air vent and lock out. Now, just to give us a warning, we're going to get some knocking on this heating system because this heating system does have its flaws. It's a system that I have made that works within this application, and since the boiler is not very far beneath the height of the radiators, you know, when you do things like shut it off and open it up at one time, you will get a little occasional banging, and pretty much what we're going to have to do is let that ride out and let the system stabilize itself before the water will make its way back into the return line and back out of the radiator. Now, I also wanted to make some mention of this here. When it comes down to steam, also with steam, plumbing supply distributors and people who work in this field are going to tell you is that steam will travel at 62 miles an hour under 2 psi, pounds per square inch, 2 pounds of pressure. They're going to say this, and it's true. Steam does travel when it's under that type of pressure, or it has the potential to move at 62 miles an hour. But the one thing that it will never do is it will never move at that speed rate in a steam heating system. You might potentially get that in a hot water system because you constantly have a constant loop and flow of water being pulled and pushed through a circulator pump. And depending on how strong that pump is, it might gain some pretty decent speed. But even then, I don't even think the water moves nearly that fast. That's actually pretty damn fast for anything to be traveling. So when people say this, that's completely inaccurate. Now, remember also, we're going to keep in mind what they said. When it's at 2 psi, yes, it travels at 62 miles an hour. Now, I will say this much. Steam can exit the heating system at 62 miles an hour once it's under 2 psi. It can exit an air vent at 62 miles an hour, depending on the type of vent that you have. If you have a vent that pops open and locks out, then you're going to get the steam traveling out of that vent at some pretty high speeds. But the one thing it would never do, it would never enter this vent at 62 miles an hour. Now, I'm going to tell you why that is. Because when you look at a radiator is essentially not much different from a hot air balloon. The radiator in a steam heating system is meant to contain the steam inside of it. The steam gets inside of the radiator, and when it gets into the air vent locks out. If you have a two-pipe system, you have a trap valve, and that trap valve is going to lock out. Once again, what's the purpose of that locking out? That's a matter of containing that steam. Can you imagine if you had steam passing through radiators at 62 miles an hour? There's only one way that it happened other than it entering or exiting that air vent at 62 miles an hour, and that would be due to if you had a severe leak, which can also come from a cutoff valve. If the lock nut is not properly packed, you can get a severe leak, and that can have water and steam gushing out of it. Or if you have a busted pipe, and that can lead to steam coming out of the radiator or out of the system at 62 miles an hour. Any way you slice it, I'm going to say this much. If you were to ever get 62 miles per hour, or let me not say 62 miles per hour, we're going to equate that to 2 psi. If you were to get 2 psi, but let me take that back for a second. Let me retract that and let me start off from this standpoint. They're going to tell you that steam travels at 62 miles under 2 pounds of pressure, but that's the key thing you got to pay attention to. If you look at a pressure control on a steam boiler and it's set for 2 pounds of pressure, 2 psi is the cutout point. That's meaning that's when it's going to max out and the boiler is going to shut down. Regardless of what the thermostat calls for, it's going to shut down because the pressure has been satisfied. There's no way the boiler fires up starting off from a cold start or even a mild start and runs complete, or from the moment it starts up, it's already generating 2 pounds of steam pressure. There's no way possible. If you're dealing with a resident, the thing is, this doesn't even happen it won't happen with residential boilers or residential grade boilers or even commercial grade boilers. They're just not built like that. Because if you actually have something like that going on in your system, what you actually have is a oversized boiler, and what you're going to have happen is return line water mixing in with your steam headers and your steam mains, and you're going to get an excessive amount of banging. You're going to get water shooting out of certain radiators. You're going to have nothing but a bunch of complications. Now, when you look at a residential boiler, and I'm going to tell you the common characteristics of a residential boiler for a small house that runs on steam. Let's say you got a 2-family house. In even cases, 4 families. I've seen residential boilers run, and the boiler, when you fire up that boiler, if you look at the pressure gauge on the boiler, you're going to notice when it first starts running, you're going to get no reading on that gauge. So my question is, how the hell is it getting 62 miles an hour when there's no reading on the gauge yet? The only time you start to get a reading on that gauge is when your air vents on your radiators lock out. Because what that does is that causes a pressure buildup. That's when your boiler starts making pressure. If you look on a residential grade boiler, and you just use a 4-family house, 2-family house as an example, in many different cases, the only time you're going to start to actually see steam pressure build up, and this is if the boiler has been running consistently for at least 30 to 40 minutes. And that's on a residential grade. Now, if you're dealing with a commercial grade boiler and you're dealing with buildings and you're dealing with boilers the size of what I run at my job, you're going to notice that boiler will build up or start to generate steam pressure within maybe about 12, 15 to 20 minutes. Then you'll start to see the gauge finally pop up and you're getting a reading on the pressure gauge. But even with commercial grade boilers, you're not going to get 2 psi entering a radiator. That never happens. The only way that ever happens as far as getting 2 pounds of pressure to enter the radiator is if you do exactly what I'm going to do in this, in the conclusion of this test, or the second test that I'm going to do, it's going to be combined in this video, is by keeping the cutoff valve off, and when the heat is on, you wait till it pressurizes, then you open up your radiator all the way. That's when you'll get 2 pounds of pressure, or possibly get 62 miles an hour of steam, but which you're not going to get that because considering the size of the opening of the air vents, it's just not big enough to allow that type of steam volume to flow through there. So you're not going to get that size momentum flowing through there. I would say the fastest you would ever get as far as steam flowing through your radiator and flowing through your heating system, maybe 2 miles an hour, 1.5 miles an hour, half a mile an hour. And I would say no faster than walking speed, than your average walking speed. Is the average speed that steam takes to travel from one location to another. Because like I said, when you first started off, you'll never get it at no 2 pounds of pressure. That just doesn't work. The only way you're actually going to do that is, number one, if you buy an oversized boiler, and that's going to be overkill. And what you're going to notice is you're going to get tons of hammering, tons of water buildup inside of your lines. You're going to get water shooting out of radiators and all kinds of chaotic bullshit. I mean, it wouldn't make any sense. So you never would actually see a boiler start to generate steam pressure before the steam even gets inside of the radiators. That just doesn't work like that unless you have severe problems in your system. The only other way you can get 2 psi built up inside of a boiler before it even heats up the system is if you actually gag that boiler. And I mean by putting a ball valve or a shutoff valve on the steam header and putting a shutoff valve on the return line. And then you fire up the boiler and let it build up pressure just like that before you actually open up those valves and release that steam back into the system. But what you'll notice, even if you do that, is once you release that steam, it's going to lose momentum and that pressure is going to die back down. Because why? It is heating a freshly cooled system, or it's heating a cooled system, and it's heating it again from scratch. So of course it's going to lose momentum. It's going to have to start all over again before it can actually build up that type of capacity. So with that being said, I'm going to start the first half of this test, and like I said, this is going to conclude of a fluke meter. It's going to conclude of a stopwatch. It's going to conclude of timing from the time that the steam enters the cutoff valve to the time that the steam gets to the air vent and that locks out. The second test is going to conclude of the cutoff valve being shut down, and once again of a stopwatch. And I'm going to let the boiler, the system build up pressure. I'm going to let it build up maximum pressure, and then I'm going to open it up once to the maximum pressure, and this is going to give us our reading. So that's how we're going to do this. So stay tuned for both tests. All right, so we got my phone right here. As you see, we got the stopwatch. I'm going to activate my fluke meter, and this is going to tell us the radiator is currently at 83 degrees, which is room temperature, 83 degrees. Yeah, I like my place a little toasty. But anyhow, we're going to wait till this thing heats up right here, and then we're going to get this going. So what I'm going to do is I'm going to point my fluke meter at my cutoff valve. And as this starts to heat up, we're going to know we'll go, as you can see, the cutoff valve sitting at 83, 84 degrees. Well, it's not room temperature. It's actually because it was the system was on not too long ago. So what we're going to do is when this heats up, I'm going to point it right back at this here. And you should be able to start to hear this thing heating up now. You can hear the air vent letting out that cold air out of the system. And I'm just checking my riser pipe to see what she's doing so I know when to start doing this countdown. Okay. fluke meter here, and we're going to see what we do. Okay, so I'm going to start my countdown right now. See the fluke meter's jumped up, 108, 10. Yep, here we go. Temperature's going all over the place. Okay, we got the countdown is going. So we're going to see exactly how long does it take. 153 degrees, 165, 168. So we're going to go from scratch. This is on a setup where we have no steam in the system just yet. It's coming up from scratch. There's no pressure in the system. Everything is starting from scratch, and we're going to see how long it takes for this thing to heat up from here all the way to the back. How long it takes to build up, or not build up pressure, but just how long does it take for it to heat up in general. The next test, since we're waiting, what we're going to do is the next test, and we'll just briefly point out the temperature of the radiator itself. The radiator, as you can see, it's still taking a little time to heat up, but over here a little closer, we got more heat. So it's going to take a little minute. The next test, how that's going to consist of, that's going to consist of what we're going to do with the next test is what we'll do is I'm going to have the system under full pressure. But what I will do is I'm going to keep the cutoff valve closed, and just to ensure that there's no steam that leaks or seeps in through this valve and slowly starts gradually heating the radiator. What I'm going to do is I'm going to also remove the air vent, and I'm going to put a plug in that air vent, pretty much gagging the radiator so there's no air that can escape out of there. And the only time I'm going to remove that gag is when I'm ready to actually start the test, and then I'll place the air vent back on. And what I'm going to do is I'm going to open up that cutoff valve, and I'm going to let the steam rush in there at full capacity, and that's going to give us the information that we need to know on exactly how long this is going to take to heat up and what's going to take longer to heat the place up, or what's going to take longer for the radiator to heat up. So we'll know whether by leaving the radiator under no pressure and letting it gradually heat up, or opening the radiator under high pressure and letting steam just rush inside of the radiator. And this is going to determine exactly how long it takes, or which is actually faster, by letting it heat up naturally or letting steam just blast inside of the radiator. Now, there's really no significance behind this test. It's just a matter of letting people know, or letting my critics know that, you know, some of your theories and the way that you back them up is really not accurate, and that's all I really wanted to prove. So that's another reason why I'm doing this. And I might also do another test with another radiator. So far we have 3 minutes into it. This is 3 minutes into the running of this system. And we are about halfway, right at the halfway mark. Okay, 3 minutes. So it'll probably be about 6 minutes before this thing heats up completely. Put the fluke meter right over here. You see we got 203. You can hear that air vent starting to hiss. That doesn't necessarily mean that it's hot yet. When you hear it hissing, all that means is that there's air pushing out of the system in this case, because if you hear the air vent hissing and you touch the radiator and it's still cold, you can keep your hands on it, you know that the air vent is not fully heated. Now on this end, you know I can't touch it or hold it for too long because the damn thing is hot as hell. Let me put the light on. Now I will admit, I do happen to like Governale cast iron convectors. Governale cast iron convectors work very well. They give off a lot of heat, and I think they're pretty attractive for a radiator that's inside of a cabinet. It's not a bad look to actually have one of these inside of your cabinet. So that's just my opinion there. And what we're going to listen for here, what I want you to listen for, is that air vent is going to click once it locks out. Once she clicks and locks out, that lets us know that the mission has been completed. That'll tell us exactly how long it took to heat up. We're going on 5 minutes. We're a little over 5 minutes now. So it'll probably be about 6 minutes. So we're going to just pay attention to this. We got 168 right here toward, zoom out just a bit. 183. Put that right there. The air vent, you see I got the little thing on there. Can you see the temperature? 90, well no, that's inaccurate. 91.94. There it goes. So let's say, okay, so it's at 5 minutes and 59 seconds, right? Let me cut this light out. So 5 minutes and 59 seconds is what it took. So, you know, I grabbed the phone a few seconds afterwards. So let's just give it 5 minutes and 50 seconds. That's how long it took for the radiator to heat up, for this valve to heat up, to lock out. So we got the time frame, 5 minutes and 50 seconds is what we're gonna go for. Temperature, so everyone sees, you can see the temperature is well over 100 and something degrees. That's a little, for whatever reason, that's not gonna get the same reading as the radiator. Once you get the harder, the heavier part of the brass. And another thing I just want to mention as a side note, some people might wonder why this here, the temperature is not saying the same as when I point to the lower part of the valve. Well, I'll say that because the lower part of the valve has a thicker brass, and I guess it holds more heat, so that's why I get a more of a solid reading. Just like when I point to the radiator, I'm pointing and it's reading well over 206 degrees, 205 degrees, 206 degrees, 210 degrees over here. So with that being said, we got the information that we need, the numbers that we need to know. I'm gonna gag this radiator, I'm gonna shut it down, and hopefully I can get another test going on in there, because I don't need any pressure. So I'm gonna cut this valve off completely. And I'm gonna remove that air vent. And then what I'm gonna do is I'm gonna do another test from scratch. Well, not from scratch. What I'm gonna do is I'm gonna have this build up pressure. I'm gonna let the system run because the thermostat is actually calling off the heat. So what I'm gonna do is let the system run. I'm gonna gag this. I'm gonna put a plug inside of this air valve. I'm gonna remove this. Now, of course, I'm probably gonna need some gloves for this. This goddamn thing is hot as hell, but of course I know how to work it just a bit where I don't get burnt. And just to let people see that this thing is actually hot. I'll open up the cutoff valve just for a second. Let y'all see the steam come out of this damn thing. So we know that there's you can hear it. So we know that there's definitely steam running through here. Of course, I can't even put my hand up there. That bad boy's hot. Let me move my phone and get my shit fucked up. You hear that motherfucker going? Kids, don't try this at home. Steam fitters, don't try this at home. I'm a professional. But you hear that shit going. You start to see the steam. Alright, I'm not going to keep this going for too long because this shit will get fucking crazy. So let me close this thing out right now and I'll prepare for the next test. Now we're going to conclude the second half of this test, which is going to prove my hypothesis. As you see, I got the stopwatch right over here. I've reset it from the previous reading that I had. I have my fluke meter, which currently the radiator is at room temperature. I can hold the cutoff valve. Radiator's cold. So with that being said, we're gonna just to give the verification on the reading. Put the light on and we're gonna cutoff valve 79 degrees. Radiator 80 degrees. So we know where this stands at. How I'm going to conduct this test now, I got the system under full pressure and I have the radiator cut off. So what I'm gonna do is I'm gonna open it up under full pressure, and we're gonna see exactly how long it takes for this thing to heat up. Now, we've seen the last results that was given. It took roughly around 5 minutes to heat up. I think 5 minutes and 50 seconds, 5 minutes, 55 seconds, whatever it was. So now we're gonna go ahead and we're gonna conduct this test now, and I'm gonna start by opening this cutoff valve and letting the steam get into the radiator. Now, I must say we're gonna get some banging here. All right, starting to heat up. And more than likely we're going to get some water coming out of the air vent due to the way this system is set up. So 54 seconds exactly. 54 seconds is what it took for this thing to heat up. So under a minute. Now, just to prove my hypothesis, the radiator is still being saturated with that steam. This air vent, let's see the temperature. The air vent says 134 degrees. The radiator, can you see it? 180 degrees. Let's say roughly around there. So under a minute. So for those who say that the radiators will heat up under or heat up faster with less steam pressure, here's the results right here. I mean, I stopped it at 57 seconds, but this thing locked out at 54 seconds. So not even a complete minute before this thing heated up. Now, of course, if you're dealing with a larger size radiator, if you're dealing with a larger size cast iron radiator, it's going to take a little longer, but the fact of the matter is, the radiator will not heat up faster under less pressure. I don't know where they come up with that conclusion from. I don't know who thought of that idea or who actually went ahead and done the test to actually prove this. And this is the one thing about me. I don't like to sit up and talk about things and go off of numbers and never have actually done the research or done the test or concluded the test to actually come to a conclusion. When it comes down to these topics, I like to actually get active, do the test myself, do the research. Once again, we can see that the radiator is piping hot. Depending on where this is at, you're going to get 150 degrees, 160. So we're at 170 or even 180. So under a minute, this radiator got hot. And surprisingly, it didn't bang at all. I thought I was going to get water shooting out of the, well, not the cutoff valve, but I thought I was going to get a lot of water shooting out of this air vent. That's another reason why I placed this towel down here, because I thought this thing was going to start leaking like crazy. But that wasn't the case. I mean, there still is some water gurgling around inside of it, but that's until it stabilizes and the water makes its way back into the return line. So once again, the purpose of me doing this test is to be able to back up my hypothesis. So when I say that steam travels faster under more pressure, that I actually am correct in what I'm saying. Now, I'm not encouraging nobody to go ahead and start boosting their boiler up to 5 to 7 psi. You don't need that much. I recommend no more than about 2.5 pounds of pressure, depending on the system, before you make any adjustments, because people will tell you it's not on your pressure, it's on your venting. And that's true, but that only applies accurately on a properly set up heating system. Now, a lot of steam heating systems, a lot of one-pipe steam heating systems have been known to give problems over the years due to pitches being tampered with. In certain cases, a building or a house will settle or shift, and the pitch will completely get thrown out of whack. So in that case, it's not even due to the system not being installed correctly. It's just due to the fact that the building settled or shifted. Now the pitches that were once in there that were supposed to re-pitch and drain everything back to their proper locations is no longer there. So you don't have the option to be able to run it like that. So the point I'm trying to make is, yes, it's not based on your pressure. It's based off of your venting, your pitching. But my key thing is, before you begin to actually tamper with your steam heating system, deciding you're going to put even more, there we go. A nice solid click out. Beautiful. Back to what I was saying. Before you decide whether you're going to tamper with your steam heating system, whether you're going to decrease steam pressure or whether you're going to increase steam pressure, know your steam heating system. Know how long it takes to actually heat up every single radiator. Know how long it takes before you actually start to build up half a pound of steam pressure in your system. In certain private houses that you're going to, and even in certain buildings, a lot of people don't think it's important to have that pressure gauge on that boiler working accurately. It's a feature that just simply lets you know what your machine is doing. But it also can let you know or determine how much heat you're putting out into your building. So for those who don't know, like I said, once again, know your system before you make any adjustments. In certain cases, you have systems that might use 3 to 5 pounds of steam pressure, and they might use that steam pressure because you have improper pitches, and they need that much steam pressure in order to get everything heated up so tenants can remain satisfied. But until you know it, don't adjust it. I use what I use here because I understand the system and I know how this one works. But the bottom line, the conclusion of the test and the purpose of this video is to prove that what I'm saying as far as using less steam pressure takes longer than using more steam pressure. You can use 2 pounds, it don't matter. But one thing you're not going to be able to do is you're not going to run it at 2 pounds or run it at, sorry about that, you're not going to run it at half a pound of pressure or start it gradually from scratch and expect it to heat up as fast as it would if it was under pressure. We've seen how long it took to heat up from end to end when it had no pressure inside of the system at all. The damn thing took over 5 minutes long to make steam pressure, damn near 6 minutes. With it under pressure, it took less than a minute. So once again, if somebody has questions that they want to ask, or if somebody says, well, no, you're going to get more steam or you're going to get faster steam into your radiator by using less pressure, at this point in time, I'm done talking. What I'm going to do is I'm going to simply refer people to this video that pretty much concludes my hypothesis, which proves my hypothesis and completely debunks everything else that other people were saying. So until next time, and more than likely I'll be posting this on my secondary channel as well, so you can stay tuned for that one. I have more videos of this in the future.